Hello, mathematicians. Today we're going to be learning about real numbers, and more specifically, how to classify our real numbers. Within our real numbers, we have two groups, which are our rational and our irrational numbers. So let's take a look at our rational numbers first. Here we have a few subgroups that you may or may not be familiar with. If we start by looking at our natural numbers, right here, we could see that our natural numbers are our counting numbers. So for example, if I wanted to count how many fingers I had up, I would start with 1, 2, 3, and so on. Our whole numbers include our natural numbers, but also include 0. A number that is not included in our natural numbers. So the difference between our natural and our whole numbers is that whole numbers include 0 and natural numbers do not. Our integers includes our natural numbers, it includes 0, and it includes negative whole numbers. So to re-emphasize, our natural numbers do not include 0. Our whole numbers do not include negative whole numbers, but our integers do. And then finally we have our rational numbers, and be mindful that natural numbers, whole numbers, and integers are all rational. However, fractions and decimals are not included within integers, whole numbers, and natural numbers. So rational numbers include natural numbers, whole numbers, integers, and fractions, and decimals. Within our fractions, we have regular fractions, we have improper fractions, and we have mixed numbers. Within our decimals, we have terminating, which are decimals that come to an end, and repeating decimals, which are decimals that have a continuous pattern. So here we have 0.014, and there's a line above the 1 and the 4, meaning that will continue to repeat. So if this decimal continues, it'll be 0.0141414, and that would go on forever. And before I get into our irrational numbers, I just want to make sure we have a clear understanding of what it means for a number to be rational. So a rational number is a number that can be represented by a fraction, a over b, where a and b are integers and b cannot equal 0. Some examples include 8 over 12, negative 16 over 8, 0 over 3, and the square root of 25. Now, if you notice, all 4 of these can be simplified, and I'm going to do just that first. So 8 over 12, we know that 8 and 12 are both divisible by 4. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So here we have 2/3. And we know that fractions can be written as decimals, so I'm going to convert this as a decimal just because. And so in order to do that, we have to divide 2 by 3. So I'll do the work on the side. And we know that 3 does not go into 2, so it goes into 2 0 times. So we're going to add a decimal and a 0. So now we have 30, we have 3 going into 20. So 3 goes into 20 6 times. So 3 times 6 is 18. So we have 20 minus 18, which is equal to 2. And then in order to continue, we'll add another 0 here. and bring that down. So 3 goes into 20 6 times, so minus 18 again. And you'll notice that the same pattern continues to happen. So our decimal here is going to be 0.66666, and that will go on forever. So this is a repeating decimal, and we write it like this, 0.6 with a line over it, indicating that the 6 will keep repeating. And now we have negative 16 over 8. And we know that 8 goes into both 16 and 8. And of course, you could use a smaller number, such as 4, and then divide it twice. But we could just use 8. So here, be mindful that our fraction is a negative. So after we divide, our fraction will still be a negative. So 16 divided by 8 is 2. And then 8 divided by 8 is 1. So we're left with negative 2 over 1, which can be simplified to negative 2, because anything divided by 1 is itself. And then here we have 0 divided by 3, and 0 divided by anything is simply 0. And then lastly, we have the square root of 25. And now we know that 5 times 5 is equal to 25. But we also know that negative 5 times negative 5 is equal to 25. So the answer here, square root of 25, is 5 or negative 5. Okay? So we're going to go back and look at the numbers we've simplified. So we know that a fraction is rational. So 2 over 3 would be rational. And we could simplify this, well actually we could convert it, not simplify it, to a decimal, which would be 0.6 repeating. And we know that a repeating decimal is also rational. Here we have negative 2 over 1, which is a fraction, and we simplify that to negative 2. So when we say that a rational number can be represented by a fraction, doesn't mean that we'll see it as a fraction. So negative 2 can be written as a fraction, so negative 2 over 1, but it does not have to be. Here we have 0. We know that 0 is a rational number. It's also a whole number. It's also an integer. And I'm just going to show you guys this fraction, 0 over 3. And our fraction is a over b. So I just want to show you guys that here, a is 0, not b. It's okay if a is 0, but it's not okay if b is 0. Because if b was 0, so if this were the case, we can't divide 3 divided by 0 because it would be undefined, and that would not be rational. So our numerator can be 0, but our denominator cannot. Here we have the square root of 25 is equal to 5 or negative 5. And we know that 5 is a natural number, a whole number, an integer, and therefore it's rational. And it could also be written as a fraction. And we have negative 5 here, which is not a natural number. It's not a whole number, but it's an integer. And it can be written as a fraction, and it's rational. So rational numbers can be simplified to equivalent fractions, repeating, terminating decimals, and integers. So all of these are rational numbers. So we're going to go back to our diagram, and we're going to talk a little bit about irrational numbers. So on the right side here, we have our irrational numbers. We have 3 examples of irrational numbers, and I'm going to go through each one and explain to you why they're irrational. So the square root of 12 is irrational because it's not a perfect square. So the closest thing we get to an integer multiplied by itself that will give you 12 is 3 times 3, which is 9, and 4 times 4, which is equal to 16. So there's no integer in between 3 and 4 that when multiplied by itself will give you 12. Therefore, if a number is not a perfect square, then it is irrational. So if it's a square root of a number that's not a perfect square, it's irrational. So pi is irrational because pi is a decimal that keeps repeating on forever. Well, it keeps going on forever without a continuous repeating pattern. So it does not have a pattern like we have here, where our decimal will continue as 141414. So the pattern is not continuous like this one. And then here we have 0.0100100001. And even though we do see a pattern here, this is not the same continuous pattern. The pattern changes. As we keep going, there's an additional 0 added. So this is not a continuous pattern, therefore it's irrational. So an irrational number is a number that cannot be written as a fraction, a square root that is not a perfect square, and a decimal that does not have a continuous pattern or terminates. So here we have some examples of irrational numbers, and I'm going to go through each one. So here we have 8.060060006, and so on. So we notice that this does have a pattern, but it does not have a continuous pattern. So in order for it to have a continuous pattern, it would have to go 8.060606 and so on. So pi is irrational because even though it goes on forever, it does not have a continuous pattern. So it's also, in other words, it's not a repeating decimal. And instead of does not have a continuous pattern, this could also be said for the first example. And the square root of 30, there's no two numbers when multiplied by itself that would give you 30. So the closest thing we would have is 5 times 5, which is 25, and 6 times 6, which is 36. So no integer multiplied by itself will give you 30. Therefore, this is irrational. So this is not a perfect square. All right, and so there you have it. That's all we need to know about rational and irrational numbers.